Hi guys, welcome back to my channel Learn to Understand, and in today's video I'm going to continue with chemistry. And I started the chapter chemical bonding, right? So we discussed about ionic or electrovalent compounds, right? I'll revise that a bit. Now what do we mean by ionic or electrovalent compounds? See, ionic compounds are those compounds. Let me just explain about ionic bonds. Ionic compounds would be understood easily by you, right? So, ionic bond or electrovalent bond. As the name suggests, it consists of ions. There are two types of ions, cations and anions. So, when two of these ions they come close, means basically they exert a force of attraction towards each other, because opposite forces they attract each other, right? So these two forces, these two ions, they attract each other, and the bond that is formed between them, that is cation and anion, this bond that is formed between both of them is ionic or electrovalent bond. Let's take a very good example of metals and non-metals. Metals have 1, 2, 3 electrons in their valence shell. That is, these are the valence electrons, right? On the other hand, if I talk about non-metals, non-metals have 5, 6, 7 as the valence electrons. So, to complete the octet, the metals have to lose these, and the non-metals have to gain these 1, 2, 3, right? So, I have explained it to you all about. Now, let's talk about the third example for ionic compounds, right? What is that third example? Calcium oxide, right? Because I explained you about sodium chloride, we had done till magnesium, magnesium chloride also. Now let's move on to the third, that is calcium oxide, right? So this is the formula for calcium oxide, right? Now if we talk about the electronic configuration of calcium, that is 2 comma 8 comma 8 comma 2, and if I talk about the electronic configuration of oxygen, that is 2 comma 8 comma 6, correct? So if I draw the valence shells or the shells for calcium, wait, let me draw again. This is the nucleus 288. Okay, again. Right. So these blacks are the electrons. 2, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, and 1 comma 2. Correct. So this is all for calcium. Right. So let's talk about oxygen now. If I see oxygen has 2 comma 8 comma 6, right? So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, right? Now calcium needs to get rid of these two electrons to attain stability. Okay. And to attain stability, oxygen needs to gain two electrons, right? So what will happen? These two electrons that are from calcium, they will go to the oxygen, right? Now after they've moved to oxygen, what will happen? Calcium would become now 2 comma 8 comma 8, and oxygen would become 2 comma 8 comma 8. They both will become stable, right? Both of them will become stable. Now after both of them have become stable, let's see what is the configuration. So a very basic thing I would like to tell you all, that oxygen's this shell, sorry, calcium's this shell is going to be deleted, the last shell, right? Now what will be the number of electrons? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, right? 2, comma, 8, comma, 8. Wait, 2, comma, 8, comma, 8. Yeah, my mistake have, okay, wait. This not be deleted. The last shell was already been deleted. I didn't see that. I deleted it. Okay, I'll do it again. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? So this is 2, comma 8, comma 8. Done. Now if I talk about oxygen, oxygen is also 2, comma 8. Comma 8, 8, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, right? So 2, comma 8, comma 8. Now if I draw the electron dot structures for both of them, let's see what are they going to be, correct? See, electron dot structures are also called Lewis structures, right? So if Lewis structure comes, then don't forget, okay? Now calcium has 2 valence electrons. On the other hand, oxygen has 1, 2, 3, 4, 5 and 6. It has 6 valence electrons. Now when calcium has 2 and oxygen has 6 valence electrons, then these will move towards oxygen, right? So it becomes Ca2 positive and it becomes O2 negative. Why? Because calcium lost 2 electrons and became Ca2 positive. On the other hand, oxygen lost 2 electrons, sorry, gained 2 electrons and become 2 negative. So this whole charge, these 2 positive and 2 negative get cancelled and it makes CaO, right? Calcium oxide. I hope so this thing is clear to you all, right? Let's move further. Let's lower the candles. Okay, let's move on to the next type of bond, that is covalent bond. Correct? See, I explained you covalent bond is formed due to the sharing of electrons, and I'll explain you also that covalent bonding. Let's change the pen's color, both from the same colors. Okay, let's use yellow today. So if we talk about covalent bonding, then covalent bonds are that chemical bond that is formed between two combining atoms by mutual sharing. So an important point to notice is mutual sharing, in which both the elements of both the atoms share the electrons. They can be pairs of electrons. This bond is known as covalent bond or molecular bond, right? It is also called molecular bond, correct? Now, if you see, the molecule formed due to this sharing of electrons becomes a covalent molecule, right? So the molecule that is formed from sharing of these, or it is formed because of the covalent bonding, then the molecule will come to be known as covalent molecule. I hope so this thing is clear to you, because it's very important for you all to understand this. Now, usually non-metals, what they have? They have an electronic configuration of 5, 6, 0, right? So in the outermost shell, this is the valence electrons, correct? So the atoms of such element, they do not favor the loss of electrons, right? They favor the gain of electrons, right? So therefore the octet of an atom can only be completed by mutual sharing one or more pair of electrons. Each atom contributes equal number of electrons, right? So non-metal combines with another non-metal, right? Because they bonded in the stable configuration, then the sharing of electrons takes place between their atoms, right? Means if a non-metal combines with another non-metal, so this bonding that's formed is covalent. Okay, now how is that possible? I'll explain you all here. Okay, let's watch the video further for a better understanding of the same. Okay, now let me start explaining you. See, if I say that I have hydrogen, that is a non-metal, right? And chlorine is also a non-metal. So when hydrogen that combines with chlorine to form hydrogen chloride, hydrogen is also a non-metal, when chlorine is also a non-metal. So when hydrogen and chlorine they combine, what do they form? They form hydrochloric acid, right? What do they form? They form hydrogen chloride, basically, you can say. So the sharing of electrons takes place between hydrogen and fluoride atoms, right? And which bond is formed between HCl? Covalent. Many people get confused that in HCl, which bond is formed? They say that ionic bond is formed. That is completely wrong. Bond formed as covalent. Now why is covalent bond formed? Because there is a sharing of electrons. What is there? There is a sharing of electrons. Correct? So I hope so this thing is clear to you. If you have any doubts, you can ask in the comment section. Now I'll explain further. Okay. So whenever a covalent bond is formed between two atoms of a non-metal, see basically if you take example of two chlorine atoms, they also combine together and form a covalent bond, right? Now there are certain types of covalent bonds. Okay. First is single covalent bond. Second is double covalent bond. And the third is triple covalent bond. Right? The third is triple covalent bond. Correct. So these are the various types of covalent bond. Right? So a single covalent bond is formed by sharing one pair of electrons. Right? Single covalent bond is formed by sharing of one pair of electrons. Double covalent bond is formed by sharing of two pairs of electrons. And triple covalent bond is formed by sharing of three pairs of electrons. Correct? Okay, now I'll explain you these things. What is single, what is double, what is triple covalent bond further. Right, first let me clear each and everything. Okay, so now we talk about a single covalent bond first, right? Single covalent. We write bond also. What single covalent? No. So in single covalent bond, it is formed by sharing of one pairs of electrons between the atoms which contribute one electron, right? One pair of electron is shared and one electron per atom. Okay, one electron per atom is shared, correct? So if we see molecules of hydrogen, chlorine, hydrogen chloride, water, ammonia, methane, carbon tetrachloride, these are some examples of covalent bonds, single covalent bonds. Right, I'll tell you how are these. For example, if I talk about hydrogen, HH, chlorine, ClCl, HCl, wait, I'll erase it. If I talk about HCl, H and Cl. If I talk about water, H comma HOH. If I talk about ammonia, H and H. And if I talk about methane, H. See, I'll tell you what are the single covalent bonds. I'll show you. First, I'm telling you the examples. In carbon tetrachloride, okay. So this is hydrogen. This is chlorine. Actually, you know this. I don't think so I need to explain you. Let's leave it. So the single covalent bond is this. See, this is only one line is present that represents a single covalent bond. Here also only one line is present that represents a single covalent bond. Here also, then again single covalent, single covalent, single covalent, single covalent, single covalent. Now where is the bond formed? How is this bond formed in these? I'll explain you. First, let's talk about each of it. That is water. A single covalent bond is formed here. Another single covalent bond is formed here. Okay. A single covalent bond is formed here. Another single covalent bond is formed here. Another single covalent bond is formed here. One single covalent bond. Another. 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 One bond. Second covalent bond. Third covalent bond and fourth covalent bond. So you can see there are various covalent bonds that are present between. These are present in a single element, right? Like if we talk about HCl, if we talk about ammonia, if we talk about water. So you all can understand that what are the different elements in which the covalent bonding is present. Correct? Okay. Now let's talk about a double covalent bond. So if a single covalent bond is formed by sharing a single pair of electrons, then a double covalent bond is formed by sharing of two pairs of electrons, right? Sharing of two pairs of electrons, correct? So two pairs of electrons are shared in double covalent bonds, right? And how do you represent it? You represent it by two lines. These are the two lines by which you will represent a double covalent bond, correct? Okay, sorry guys for this light. Next, talk about examples for it. Now, oxygen molecule, it contains a double bond. How? Let's see that. I'm talking about oxygen molecule, O and O. Okay. Then if I talk about carbon dioxide, it contains two double covalent bonds, right? It contains two double covalent bonds. Means two. Okay, I'll show you. C. Let's say this is O. Here is C again O. Double, double. Okay. This is the type of bonding. If I talk about another example, see, these are okay, oxygen molecule and carbon dioxide molecule. The best examples for double covalent bonds are these. Okay. Now I'll explain you about the triple covalent bonds. Okay, so triple covalent bond is formed by sharing of three electrons. Triple covalent bond. So triple covalent bond is formed by sharing of three pairs of electrons. Okay, now three pairs of electrons, right? If I say that nitrogen molecule, a nitrogen molecule also contains a triple covalent bond. So this is the way you write nitrogen molecule. And I'll show you the bonding present in it. This way, one from two. So triple covalent bond is represented by three lines. This is a triple covalent bond that is present in it, right? Sorry. Now let's talk about ethene. Ethene also has a triple covalent bond. H, H, carbon, carbon, H, H, right? So this carbon, what have we written? Just a minute, students, I'm erasing it. Okay. Now again a carbon. So double covalent bond in it. Hydrogen, 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 hydrogen. Right? Now see, if you can see ethene molecule, it has double covalent bond and four single covalent bonds, right? So this is not an example of this. I'm showing everything ethene so that I can show you that two types of bonds can also be present in a single element. Two types of bonds can be present, right? I hope this is clear to you. If not, then tell me in the comment section below. I'll surely make a video for your clarification of the doubts, right? In a similar manner, if you talk about ethyne also, then ethyne, it also has many bonds. The formula for ethyne is C2H2. Then Why this is C, okay? I'll write it again. C2H2, right? So the bonding is such this way. Just a minute, let me erase this. So the bonding is this way. This is what? This is ethyne. Correct. Now let's study about polar and non-polar covalent compounds. Right. So if I talk about polar covalent compounds are those compounds that are formed due to unequal amount of sharing of electrons. Means unequal electrons are shared in polar covalent compounds. On the other hand, if I talk about non-polar covalent compounds, equal sharing occurs. Right? So first I'll discuss about polar covalent compounds. Polar covalent compounds, they are those which have equal sharing of electron. Right? So this is clear to you, but I'll explain all of them. Again, I'll explain you. But I think so you all know that HCl is a polar covalent compound. Right? So this thing should be very clear to you that what are the polar covalent compounds. I'll explain you both of them right now. So guys, in the polar covalent compounds, they are said to be polar when the shared pairs of electrons are not at equal distances between the two atoms, right? Means if I say X and Y are the two atoms, यहाँ पर है shared pair of electron. अब देखो इसके पास है, इसके दूर है, तो that is polar. जब थोड़ा सा वो होता है unequal, ठीक है? Distance is unequal, correct? Okay. Now let's talk about the examples of polar covalent compounds. So there are certain examples of polar covalent compounds such as HCl, right? HCl is a very good example. Water molecule and ammonia and hydrogen molecules, hydrogen fluoride basically, HF. So these are all examples of polar covalent compounds in which equal sharing of electrons occurs. But what is the thing that at wider distance and at some it is found at a narrower distance, right? Now if I talk about non-polar covalent compounds, I really love this color. Non-polar. If you love it too, then tell me in the comment section, right? Non-polar covalent compounds. So non-polar covalent compounds are those compounds that have equal sharing of electrons, right? Let's take an example of hydrogen molecule, chlorine molecule, oxygen molecule. These are all perfect examples of non-polar covalent compounds. Okay, now I'll show you some structures for I'll show you only one structure for polar covalent. Wait, let's erase non and only that let be polar, right? I'm going to explain the structure for polar covalent. I'm going to draw some structures, two structures I'm going to draw, right? Okay, so the first structure is of water. This is a slight charge. Hydrogen is positive. Okay, this is bonding present in water molecule. If you want to understand the bonding present in ammonia, I can draw that also. Wait. This is a type of polar covalent compounds. If you want, I can show you more also. Okay, let me show you for hydrogen fluoride. That's the last one. This is a type of bond that is, sorry, draw drawn plus here. So sorry for this mistake. This is the polar covalent compounds examples, right? So this thing is clear to you all, right? Now see, the process by which the covalent compounds are converted into ions is known as ionization. I hope this process comes further so that I can explain it to you in a better detail. If not, then I'll explain, make a video especially for ionization and dissociation, and I'll explain you that, right? Though it has to be coming in the chapter electrolysis. That is the 6th chapter of ICSE Selena concise book. Okay. Now, the more is the electronegativity difference between two atoms forming a bond, the more is the polar nature of the molecule, right? Now, if the bond formed between two atoms and with the same electronegativity is non-polar, with slightly difference in electronegativity is polar, and with much electronegativity difference is ionic. Okay, I hope so this is clear to you all. Now, since a polar covalent molecule has both a positive and a negative charge, it is also known as a dipole molecule. Okay, a polar covalent molecule. It's an important point, guys. A polar covalent molecule is also called a dipole molecule, right? What is also called? It is also called a dipole molecule, correct? Alright then, let's move further. The conditions that were required for the formation of a covalent bond. Okay, let's change the color. These are all colors that we use daily. Okay, conditions required for the formation of a covalent bond. For the formation of a covalent bond, right? The first condition is both atoms should have 4 or more electrons in the outermost shell, right? Both atoms should have 4 or more electrons. Both atoms should have 4 or more electrons in the valence shell. That is, they should have more than 4 valence electrons, right? Second is both atoms should have high electronegativity. I'm writing high. This is representing high. Third is they both should have high electron affinity. Tell me if you want a video on this electronegativity, electron affinity, IP, right? Anything if you want. Both atoms should have high IP. High IP. I'll write it properly. Fifth is that the electronegativity difference between the combining atoms should be 0. Electronegativity difference should be 0 or negligible. Correct, students? I hope so this is clear to you. These are the basic example. Basically, these are the conditions that are required for the formation of a covalent molecule. Correct? Right. So I hope so you like the video. If you like it, then please press the like button, and if you thought that this video provided a good content to you, then do subscribe to my channel for more such videos. And if you think that this video would be helpful to others too, then do share this video. If you think that I provide you with good content, then do press the bell icon if you want to receive the notifications first, right? So, and if you have any doubts, then do tell me in the comment section below. I'm surely going to clarify all the doubts. Okay, so meet you in the next video. Till then, stay safe and thank you.